have made a lot of progress so far, right? I gave you the weighted average cost of capital formula, or the WACC short, right? And we have estimated almost all the numbers that we need, right? The required return on debt, 4.2, the required return on equity, 5.5, right? But there is one more set of numbers that we need, which is the ratios, right, that tell you how the company is financed, right? And by the way, we also need taxes, right? But if you look at Module 2, we were doing a financial planning of PepsiCo. We already figured out that 25% is a reasonable estimate for the tax rate of PepsiCo. Okay? So what we need to find out now is how PepsiCo is financed. And let's go back to Module 1. Okay? You need to use the market value of equity. Okay? If you want to measure leverage, how much leverage a company has, right? The right way of doing it is by using the market value. Okay? It's very tempting to do this using book values, right? If you take standard data sources like Morningstar, okay, in many cases they will be reporting capital structure data for you, right? There's even, using these nice pie charts, right, as the one you have there, right? We can think of the company as a pie, and then, who is eating the pie, right? Debt holders and equity holders are eating the pie. These pie charts are kind of cool to represent capital structure. The problem is that if you look at the underlying data, which is here, okay, that pie is representing book values. Okay, the equity value here in the pie is 15 billion, but when you look at the actual data on the market value of PepsiCo, right, the market cap is $138 billion, which is a lot more, right, than the book value. We talked about this already in the course, right, when we were discussing leverage. The book value of equity is a poor proxy for the value of the equity because it ignores the future, right? Most of the value of the equity for a healthy company like PepsiCo is going to be in the future, and the book value completely ignores that. So that's a problem, and the way we fix this problem is by using the market value, right? So let's just go here to recap how we do this very quickly, right? We have here data on that. We're going to use the market value, right? So our DV is simply going to be 30, the market value of that, divided by 30 plus 138. Okay, so here's the market value of equity, not the book. You should find a leverage ratio of 19%. A debt over debt plus equity ratio is 19%. Okay, so 19%, right? If D over V is 19, obviously E over V is going to be 81%. Okay, so it should be easy to do, but I bet if you hadn't taken this class, you would end up using book values to estimate this. So that's the point I really want to emphasize. Okay, so here's the entire calculation, right? We have the WACC, which is 5%. Okay, what we're doing here is multiplying the cost of equity by the contribution of equity to the firm value. Okay, so before we talk about the interpretation of the WACC, let me make a few points here. The first one is that it is very important to use market values, right? Think about this: the cost of debt is lower than the cost of equity, right? The required return on debt is lower than the required return on equity. So if you were using book values here, you would end up with a lower cost of capital. It's not what you want to do, right? You would be biasing down the cost of capital, as we're going to learn next when we measure performance. That's a big problem. Okay? The second point is that you have to remember this is not a magic number. We do not have a crystal ball. This depends on estimates. In particular, the WACC is very dependent on the beta, right? If the beta goes up or down, the cost of capital for the company is going to change. So here is a little table for you, right? We were working with a range of 0.4 to 0.7 for the beta, right? That range is going to imply a range of approximately 4.5 to 6% for the cost of capital. Okay? So if you want to be conservative and use 0.7 as the beta, the cost of capital would be 6%. Okay? In any practical application, you do want to do the sensitivity analysis when estimating WACC. Okay? It's simple. It should be relatively straightforward to do, and it's going to help a lot when you are using cost of capital to value projects, to do performance evaluation and things like that. Okay? Talking about projects, let's learn how we use WACC. Okay? So here's a question for you, right? The WACC is the discount rate for the company, right? That was our starting point, right? We talked about the fact that we're going to use the WACC to estimate the discount rate for the company, okay? So the way to interpret it is that is the required return on projects that have risks similar to the company, right? So let's see, just to make it clear that we all know how to use it, consider the following example. Suppose that PepsiCo is developing a new soda, right? Which should be similar to the company as a whole, right? What is the minimum IRR? Going back to Model 3, think about IRR, but now think about what is the minimum IRR that PepsiCo would need to generate to make the soda positive NPV, okay? What is the required IRR, the required rate of return in this case? Now we know the answer, okay? The answer is that the IRR has to be greater than 6%, right? The cool thing we just figured out is that now we can actually estimate that number, right? The 6% is not falling from the sky anymore. The 6% is the cost of capital, okay? It's not a perfect estimate, right? Like all estimates we use when we do finance, we have to use statistical analysis, common sense. It's not a number we know for sure, but it's better than just guessing, right? So we know that the WACC is not 10%. That we know, we can pretty much be sure of that, right? There is a possible range for the WACC. 6% is a reasonable estimate, right? And plus, given our analysis, 6% actually turns out to be a conservative estimate for the cost of capital for PepsiCo, right? Because we are using the high end of our beta estimates. The bottom line, going back to Model 3, right? We need the IRR to be greater than the discount rate, right? If the IRR is greater than the discount rate, the NPV is positive, right? So what this all means is that for a new soda, for a project that looks like PepsiCo, all it needs to do is to generate a return greater than 6%, and we are pretty sure that this new soda is going to be positive NPV.